So I'd like to look at how to write the formula for a trig equation if you've just been given the graph to look at. And the first thing that you have to do is make sure that you actually know the basic standard transforms for it. So you kind of have to memorize, if you haven't memorized already, the format for these guys. So in here, we know that A is going to be the amplitude, and that is from the equilibrium, which is the middle. You'll see how that looks in a second. B is related to the period, but it's not the period, but this is basically telling us how quickly it cycles between the different peaks and troughs. And D is telling us where the equilibrium is. And this is, in fact, going to be your midline, if you want to think about it that way, your midline of the graph. So the next thing that you need to know is if you can memorize what these basic formulas are, a sine b x plus d or a cos b x plus d, we have to find that information about a, b, and d. But the other big step there is that you've got to actually figure out whether to use the sin or the cos. So sin graphs always start at the equilibrium. Not that that's exactly well balanced. They always start at the equilibrium. They don't have to be centered on the x-axis. They can go negative first and then positive. But you'll notice for both of these, they're starting at the equilibrium. So that's the key for us. Sin start at equilibrium. Now for your cos, other way around, these always start at either a peak or a trough, a max or a min. So for instance, it could start at a max, come down, and then go back up to a max, and come down, go back up to a max. So you're noticing here it's starting at its maximum and going down. You could also have one that starts at a minimum and goes up. You could also have a graph, I guess that kind of is both of them. Yeah, so in either of these cases, you'd have to be able to identify, okay, should I use cos or should I use sin? And your big key for that is where it starts. And so here, cos starts at max or min. And then you also have to watch for your signs. If it starts at the max, it's a positive cos. If it starts at the min, it's a negative cosine. So cos always starts at a min or a max, but if it starts at the min and increases, it's going to be a negative cos. If it starts at the max and decreases, it will be a positive cos. For sin, similar, to figure out positive and negative, if it starts and increases, so it goes to a peak first, positive sin will be a peak first, and negative sin is when it goes to a trough or a minimum first. Okay. So looking at the image of the graph, you have to actually decide, or from the word problem, am I starting at the highest possible point? Am I starting at the equilibrium? Am I starting at the lowest possible point? Which of these two equations is going to be the important one? And once you've figured out which equation to apply, we can then start solving for the A, the D, and the B. So, looking at this first example that we've got here, I've given you a little bit of information. You notice that this is y and x. It starts at peak of 8, goes down, back up, and I've given you this information that it goes until 3 seconds at that particular point. Now the key fun for that is being able to remember what our period and our amplitude are again. So like we've done before, to find the amplitude, in this case, the amplitude is going to be the max minus the min. So here 8 to 0, which is equal to 8, divided by 2 is 4. So I know my amplitude is 4. Now to get D, or my equilibrium, I'm going to go my max, which is 8, minus 4, which is my amplitude, and that gets me to 4. So again, that comes from over here. My amplitude is max minus min divided by 2, and for D I can use the max minus the amplitude, and that gives me D, the equilibrium. So what you could imagine here is at 4 seconds, sorry, at a height of 4, that's where it oscillates between up and down, going 4 above, 4 below, 4 above, 4 below. The next thing for us is to find the period. Now the period again is one complete cycle, so if I'm starting at a max, I have to go to the next max. That would be one period. So from max to max gets me a period. And in this case, the graph is mean. It hasn't given me enough information to know exactly how long that is. So I have to think, okay, what's the information I do have? I know that I have a total of 3 seconds, and how many parts of a period has it completed in that time? That's one period, and this is just going from max down to min. This is half a period. In that next little time period, just a half. So that's a total of 1.5 periods that it's covering. So to find out what the actual period is, how long it takes for one, is I'm going to take that 1.5 divided by the 3 seconds. Sorry, other way around. I know that in 3 seconds it completes 1.5, 1.5 periods. So if I divide 3 by 1.5, I get 2, and that's my period. So this is looking at, if you want to see it, this is the total time divided by the number of cycles or periods in there. So that's how I'm finding the period if I can't read it directly off the graph. So again, that total time is 3 seconds, and I know that it completes 1.5 cycles. So 3 divided by 1.5 gets me 2 seconds for the period. And that's the information I need. So now, going with my formula, y equals something. So remember, we hadn't actually talked about it for this one, but I need to pick a formula. Is it sin or cos? So remember, sin starts at equilibrium, cos starts at a max or a min. If I look at this problem, it started at a max, so I know it needs to be a cos, and since it started at a max, it's a positive cos. So I'll use cosine, and my a is going to be 4, cos, my b, oh, sorry, haven't done my b yet. One step far ahead of myself. B, I've got my period as 2, but I need to find what actually b is. And b, you have to have a second formula to memorize to solve for it. It's 2 pi divided by the period. So now that I know my period is 2, b is going to be equal to 2 pi divided by 2, and that is just equal to pi. Now, don't plug pi into your calculator, don't turn this into a decimal, just simplify the numbers in front, whether that's 7 over 8, or 5 over 3, or 2 over 2, simplify that however you can, or leave it as a fraction, and leave the pi there. So this in fact is just pi, and now I can write my formula. Y is equal to a, which is 4. This is going to be a cos, bracket b, which is pi, x, plus d, which in this case we found to be 4. So that's my formula there. So one thing that you do want to keep in mind is that it's probably a good idea to put the brackets in there around the bx, just to make sure that if you're putting it into a calculator or you're talking on a graph with it, that you know that that's the pi and the x that are being given to the function cosine. Okay, so again you have to choose your formula, whether you're going to use cos or sin. You need to then find your amplitude, and your amplitude comes from the max minus the min divided by 2. So the highest point to the lowest point divided by 2. D is your equilibrium, or your midline, and you can find that by going max minus the amplitude once you have it. Finding the period is an important middle step, so you need to find the period, and you can do that by doing the total time divided by the number of cycles or periods shown, or read it directly off the graph if you can. For instance, had this said 2 seconds there, I would have known my period is 2 seconds and not have to do the calculation. Then you need to use that information to find B, and then plug the information into your formula. A here is 4, B is pi, and D is 4. Okay, I'm going to do a follow-up with a few more of those as practice, so give a go with them on your own when you start up the video before you actually press play, and see how you go with it, or watch through it if you just need more help and more advice on it.